Okay, welcome back. So now I want to talk a little bit about integers. So now in math, there are a lot of classifications of numbers. So for example, something that's very commonly used is the usage of natural numbers. So now natural numbers are basically the numbers that we use when we count naturally. Like if they tell you to count, something that we might begin to do is begin to count with our fingers. So we would start with 1, 2, 3, 4, 5, and we can keep on going forever. And those are the natural numbers. Now, when we talk about whole numbers, basically, we just add a 0 into the mix. So now we would have 0, and then we would have 1, 2, 3, 4, 5, and so on. Now for integers, we take it one step further. We use all of the whole numbers, and we use negative numbers as well. So we can kind of think about beginning with -3, -2, -1, 0, and then 1, 2, and 3. And again, these 3 dots mean that the pattern is going to continue on forever. So we would have 4, 5, 6, so on and so on. And then the same thing from the left, -3, -4, all the way to, well, we would never succeed in counting all of the numbers because we have an infinite amount of numbers. So now there's a very special symbol for integers. There were a lot of German mathematicians that contributed a lot to the language of mathematics. So in German, the word for number begins with a Z, and hence why we use a special striped Z to denote the set of all integers. So again, I just want to point out that integers are these kinds of numbers, and I'm going to be referring to them for the next examples. Alright, so let's take a look at some examples. So here it says, list all of the integers that exist in the given interval. So now let's look at our endpoints. So we have a -2 and we have a +3. So let's imagine creating a number line here. And we have that -2 is the lower bound. So that will be the starting position. So we begin at -2, and then we're going to begin counting to the right. So to the right of -2, we have -1, then we have 0, then we have 1, 2, and we're going to stop at 3 because that is the upper bound. And the upper bound is basically our ending position. So now we notice that here we have a bracket, and then here we have another bracket. So we actually have a closed circle on the left, and we have a closed circle on the right. So now that's going to be useful for determining all these solutions, because when you have a closed circle, that means that -2, or the number that's below it, is part of the solution. So then here on the right, we also have another closed circle, so we can say that the 3 is also going to be part of the solution. Now we have to list all of the integers that are solutions to this interval. So then we can say the solution set is going to be -2, -1, 0, 1, 2, and 3. Alright, let's try one more. So now it says, again, list all of the integers that exist within this interval. So this time, my starting position is going to be 5. And we're going to count all the way up to 11. So 5, 6, 7, 8, 9, 10, and 11. So now, on my lower bound, I have a bracket. And my upper bound, I have a parenthesis. So above 5, since I have a bracket, I'm going to shade this circle. Now on 11, since I have a parentheses, I'm just going to leave it open. Whenever we have an open circle, we say that the number below it is not part of the solution. So now, in order to write the solution set, we're going to begin with 5 because we have a closed circle, and that means that the number below it will be part of the solution. We're going to write 6, 7, 8, 9, 10, and we will stop at 10 because that is the final integer that's a solution to this set here. Actually, let's just do one more. So we have negative 9, 0. So here we begin at negative 9, negative 8, and again we always start from left to right. So negative 7, negative 6, negative 5, all the way to 0. So now here we have a parenthesis on the left and on the right. So above negative 9 we have an open circle, and above 0 we have another open circle. So now this tells us that the negative 9 is not a solution. And again, likewise on the right, the open circle tells us that 0 will not be a solution. So all of the integers that are solutions within this interval are going to be, we're going to begin with 8, negative 8, and then negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, and negative 1. That would be my solution set. Alright, cool. So try these problems out and check them out.